Welcome to Contact 1, Introduction to SPSS and Data Handling. In this session, we will introduce SPSS as a structured tool for econometric analysis and learn to classify variables correctly. We will also demonstrate how to import and clean economic datasets for policy relevance. Good afternoon, everyone, and welcome to this course titled Basic SPSS for Applied Research. I am Dr. Lawrence, and today we begin our journey into SPSS. Think of SPSS as your research kitchen. It helps you prepare, cook, and serve the meal of analysis. But just like cooking, you must understand your ingredients. In this case, data types, transformations, and statistical tests before you start clicking buttons. In this contact, we will move step by step from the basics of the workspace to importing and cleaning real economic data. First, we explore what SPSS is, why it is popular globally, and specifically how economists use it to drive governance. Economists rely on SPSS for structured data management, ensuring that complex indices are handled with more precision than a standard spreadsheet. Next, we define variable types, nominal, ordinal, interval, and ratio, using clear examples to ensure correct statistical handling. Correctly classifying your data is the foundation of any valid analysis. It dictates which tests you can perform and how you interpret results. Third, we navigate the SPSS workspace, distinguishing between the data view and variable view to define our measurement scales. This is where you define your variables, assign labels, and set the measurement scales that SPSS uses to calculate your outputs. Then we move to importing data, bringing real data sets like Nigeria's GDP directly from Excel into the SPSS environment. Ensuring proper variable recognition during this stage prevents errors and maintains the integrity of your economic evidence. Finally, we tackle cleaning and transformation, such as handling missing values, computing log GDP, and calculating growth rates. These transformations allow us to interpret economic meaning, linking our analysis directly to policy issues like unemployment and growth. By the end of this session, you will confidently navigate the workspace and perform basic transformations to interpret real-world data. In our next contact, we will dive deeper into descriptive statistics and how to visualize our findings effectively. You will not only know how to click through SPSS menus, but also understand the statistical theory behind each step. I'll see you in the next session. Introduction to SPSS and Data Handling, Part 1. Greetings, everyone. Welcome to our journey into SPSS, the statistical package for social sciences. Think of SPSS as your research kitchen. It helps you prepare, cook, and serve the meal of analysis. But just like cooking, you must understand your ingredients, in this case, data types and statistical tests, before you start clicking buttons. SPSS was developed in 1968 to help social scientists analyze survey data quickly. Today, it is used globally in health sciences, business, political science, and economics. SPSS is popular because it is accessible. No coding required. It produces neat tables and charts, and its interface feels familiar like Excel. But beware of mindless analysis. Clicking t-test without knowing it compares two means leads to meaningless results. By the end of these sessions, you will confidently use SPSS for econometric analysis, understand the statistical theory behind outputs, and present findings professionally in PowerPoint. Before we click anything, let's recall the theory of measurement scales. Econometrics is not just about pressing buttons. It's about understanding the meaning behind the data. There are 4 types of variables: nominal, ordinal, interval, and ratio. Nominal variables classify data into categories without order. For example, gender or nationality. Here we see the variable view where measure is set to nominal and the resulting frequency table. Ordinal variables have a meaningful order but no fixed distance. For example, education levels. In SPSS, we set these specifically to ensure the software respects the ranked order. We set the measure to ordinal for education. When we run a crosstab with satisfaction levels, we get a clear contingency table that respects our ranked data. Scale variables cover interval and ratio data. Interval has equal spacing but no true zero, while ratio has a meaningful zero, like our economic indicator, GDP. By setting GDP as scale in variable view, we can run descriptive statistics to see the mean, standard deviation, and range of our economic data. GDP growth rate is one of the most important indicators of economic performance. A positive rate means expansion, a negative rate means contraction, recession. Unlike Excel, SPSS requires us to declare whether a variable is nominal, ordinal, or scale. This prevents mistakes when running statistical tests and maintains the integrity of your research. I'll see you in the next session. Contact 1, Part 2, SPSS Workspace. Now that we've reviewed the theory of measurement scales, let's move into SPSS itself. Think of SPSS as a structured laboratory for data. Unlike Excel, which lets you type freely into cells, SPSS enforces discipline by requiring you to define variables and their properties before analysis. This prevents mistakes and ensures that the statistical tests you run are valid. This is the SPSS workspace. Notice the menu bar at the top. These are the tools we'll use for importing, transforming, and analyzing data. Notice how organized these menus are. Each one serves a specific stage of the research process, from initial data cleaning in Transform to the core econometric modeling found under Analyze. Notice when we switch to the Data View tab and type a number, SPSS automatically names this variable VAR0001. Each row here is an observation, and each column is a variable, just like a spreadsheet. But we can't stop at VAR0001. Good research requires clear metadata. We need to tell SPSS exactly what that variable represents, which brings us to the most important tab in the software. In variable view, we define the metadata, its name, type, label, and scale. Here, we rename our variable to year and add GDP. Notice how we set GDP as a scale variable, because it has a true zero and can be meaningfully compared. SPSS also allows us to control formatting to ensure our data is readable. By setting GDP to 2 decimal places and right justifying our numeric values, we maintain professional standards in our datasets. These small steps, like setting decimals and alignment, ensure clarity and consistency. It might seem minor, but it's vital for professional econometric reporting. Imagine trying to run a regression with GDP as a category. The results would be meaningless. SPSS forces you to declare the variable type upfront, ensuring the reliability of your econometric analysis compared to the free-form entry of Excel. Now it's your turn. Set your GDP as a scale variable. Remember why we do this. It allows for ratio comparisons and ensures the statistical tests we run are valid for the data we have. By mastering these properties, you ensure your analysis is built on a solid foundation. In our next segment, we will tackle the crucial step of importing Nigeria's GDP dataset directly from Excel. I'll see you there. Introduction to SPSS and Data Handling, Part 3. Now that we've mastered the SPSS workspace, it's time to bring in our actual data. In applied research, your data often starts in Excel. Today, we will demonstrate the professional workflow of importing Nigeria's GDP dataset directly into SPSS for analysis. Before we touch SPSS, your Excel sheet must be clean. Ensure your variables are in the first row and that there are no empty rows or mixed data types in your columns. This preparation prevents common import errors. Remember, the discipline we discussed in Part 2 starts in your spreadsheet. SPSS will attempt to recognize your variable types automatically, but it relies on your Excel data being consistently formatted. To begin, go to File, then Open and select Data. Change your file type to Excel and select your GDP dataset. SPSS will then present you with the Import Options window. A crucial step here is checking the box. Read variable names from first row of data. This tells SPSS to use your Excel headers as the metadata we practiced defining earlier. Notice the preview window in SPSS. It shows you exactly how your columns will be mapped. Verify that year and GDP are being recognized correctly before you click OK. Once imported, your first stop should always be the variable view tab. Even with a perfect import, you may need to double check that your GDP is set to scale and that your labels are descriptive for your final report. Here is our successfully imported data. Each row corresponds to a specific year, and our GDP figures are ready for transformation and econometric modeling. I encourage you to try this with your own datasets. Mastering the import process is the gateway to using SPSS for sophisticated policy analysis and economic evidence. To recap, start with a clean Excel file, use the import dialog correctly, and always verify your metadata in variable view before you begin your analysis. Now that our data is in the system, we are ready for the final step of our first contact, cleaning and transformation. We will calculate log GDP and growth rates in our next segment. I'll see you there. Contact 1, Part 4, Cleaning and Transformation. With our Nigeria GDP dataset successfully imported, we now move to the most critical stage of data handling, cleaning and transformation. Raw data is rarely ready for analysis. We must first ensure its integrity by handling missing values and then transform it to reveal its economic meaning. Missing values can bias your econometric results. In SPSS, we can use the Replace Missing Values tool to handle gaps in our series, ensuring a continuous dataset for our regression models. Handling missing data is about precision, not guesswork. Whether you use mean substitution or linear interpolation, your choice must be theoretically sound to maintain the validity of your economic evidence. Next, we compute log GDP. Economists use log transformations to linearize trends and reduce skewness. In the compute variable window, we simply use the natural log function to create our new log_GDP variable. By using log GDP, we can interpret percentage changes more easily and stabilize the variance in our data, which is essential for accurate forecasting and policy modeling. Finally, we calculate the GDP growth rate. In SPSS, we use the lag function to compare current GDP with the previous year's figure, allowing us to quantify economic expansion or contraction. These growth rates are the pulse of an economy. They tell us if we are in a recession or heading toward growth, linking our statistical outputs directly to real-world policy issues like unemployment and inflation. We have covered a lot in this first contact, from navigating the SPSS workspace and classifying variables to importing and transforming real economic data. You are now equipped with the foundations of econometric data handling. Congratulations on completing this introductory journey. Remember, SPSS is your research kitchen. Keep practicing your recipes of analysis, and I will see you in our next contact to dive into descriptive statistics.